Good afternoon, everybody. Happy Monday. Happy Monday. Hope everybody's well. Had a good weekend. All right. I see there's only two people who worked on that cell transport worksheet, but we want to look at cell transport and then I'll give you time to look at that lesson again. So log into Canvas. Let's look at cell transport. And then I'll give you time to work on that worksheet. So we'll talk about that after we finish looking at what we mean by cell transport. We've got a couple of vocabulary words we need to be aware of. And I'm going to go ahead and show the video in case some of you haven't watched it yet.
One of the most important and complex structures of the cell is its outer boundary, known as the cell or plasma membrane. The cell membrane serves two main functions. It protects the internal parts of the cell, and it regulates which substances enter and exit. The cell membrane is selectively permeable, restricting the flow of traffic into and out of the cell to specific molecules. It, in essence, acts as a gatekeeper. The cell membrane consists of phospholipid molecules and proteins. A closer look at a phospholipid molecule reveals that it is composed of a hydrophilic or water-seeking head and a hydrophobic or water-repelling tail. The phospholipid molecules that make up the cell membrane are in constant motion. Proteins that help make up the cell membrane perform several important tasks, including transporting molecules into and out of the cell. Some proteins act as small pumps, actively transporting molecules from one side of the membrane to the other.
All right. So the basic thing you need to understand is the cell membrane. Remember I told you that you think of the cell membrane as a screen like on your window. If you were to throw a bucket of dirty water at the screen, it would allow some of the dirt to go through and some of the things you would not see going through that screen. Okay, because it acts as a barrier. So it allows some things to pass if it's small enough to get through the little pores, and it keeps all the larger things out. Now, the cell is very intelligent. It knows what it needs to have inside and what it needs to keep outside. But sometimes, like our macromolecules that we talked about earlier in this semester, they need to get into. So the cell has to have a way of getting things to that they really want outside that are too small to just flow through the membrane. They have to have a way of getting those things in too. So we have two types of transport, passive and active. So vocabulary wise, they passive is like some of y'all. Y'all just sitting back chilling and allowing things to just flow, 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 flow. That's passive. Okay. Active means I want something done. I got to actually do it. Okay. Which I need some of y'all to do, which some of your grades. You actually have to do it. Okay. So those are the two vocabulary words. So passive transport is the movement of molecules. And then this is part is important too. This is a rule that you have to remember. Things flow from an area of high concentration to an area of low concentration. And if it's passive, it does it without energy. Like I said, the cell can just sit back and let's watch these things flow from an area of high concentration from an area to an area of low concentration without energy. And that's the important part about that definition. Think of being in a crowded elevator. We would consider that to be a area of high concentration. As soon as the doors open and there's an open room there with empty room, the molecules or the people want to get out of the crowded elevator and flow into the empty room, and they're going to spread out. Okay, so that becomes the area of low concentration because there's no people in the room, but all the people were in the elevator. High concentration, elevator, low concentration, the room. Okay, so the flow of energy is going to be going from where everything is crowded and close together to where they can spread out. Okay, that's what we mean by going from a high concentration to low concentration. All right, and we call this, the membrane itself is called a concentration gradient, which means it's the thing controlling which way the flow is moving. So it's referred to as a concentration gradient. Okay, and then we have these other two words, diffusion and osmosis. So there's a difference. Both of them are the movement of molecules. Diffusion is the movement of molecules in general. Osmosis is referred to just water. Okay, so when water moves from across the cell membrane, we call that osmosis. Okay, so it can just calmly go through, or we can have this other word here, facilitated. Facilitated means you give it a little help. Okay, in the video that you just saw, you have those channels in the membrane that open and close. So they let things go in by opening and closing. Okay, got one more person to let in. All righty. Good afternoon. We are in Canvas and we are looking at cell transport. All right, trying to get an understanding of the difference between passive and active transport. All right, so passive again means no energy. It just sits back and allows things to flow through. And it has a direction of flow. It goes from an area of high concentration to an area of low concentration. But this does work both ways. So if the materials that they want outside the cell, if that's a high concentration, then the direction of flow is going to go into the cell. But you can't have all this. What do you think? Somebody just type in the chat. What do you think is going to happen if it just keeps going into the cell and there's no control? You have a little animal cell and things are just flowing through passively. What's going to happen? What do you think is going to happen? Somebody type in the chat. Talk to me today. Or come off mic. Yeah, that's good too. That's even better. That's faster. And folks, and feel free to do that from time to time. Just unmute and ask a question or answer a question. Like right now, I'd like an answer to my question. What do you think is going to happen to the cell if materials just keep flowing? So pretend this is a balloon. What do you think happens when you just keep putting air into the balloon? What does it do?
It's going to explode.
It's going to explode. And Isaiah said it'll pop. All right, so that's what's going to happen to the cell. We have, or it will lyse. I like that word. Thank you. Vocabulary, vocabulary. All righty. So yeah, so the cell has mechanisms to control that. So when too much stuff comes in, it has a way of pumping it back out. Same thing in the cell. We said it has to go through the life processes, which means it digests and breaks down materials, and then it wants to let some things out. So it has a way of, if the materials are too much inside the cell, that now is the area of high concentration. It can send it back out to the area outside now that it's low concentration. But the rule is always to go from high to low. Later on, we'll talk about what we call reverse osmosis, where it goes against the so again, that word concentration gradient means that it's following the rule going from high to low. But later on, we're going to talk about something that goes against the concentration gradient, which means it does it in reverse. All righty. So active transport, again, means that it uses energy to actively bring materials into the cell that it wants to have. And those are usually molecules that are too big to go in by themselves. So again, like they showed you in the video, there are little pumps, and then we're going to look at these two words, exocytosis and endocytosis. Now, let me see if it's what's in here first. Okay. I tell you what I'm going to do. I'm going to stop sharing for a moment. You all look at this, um, these for a second, and I'm going to. So you want to make sure you read these, look at these, and I'm going to get you a load up something for you as soon as I do attendance. Okay. So go through this, click on these, and we're gonna. And
Diffusion occurs down a
okay,
concentration
hold
gradient.
on.
Diffusion is the net movement of a.
Actually, let me do this first. So can I restart it? It won't let me restart. Hold on. All right, we'll start from here.
Substance from an area of high concentration of that substance to one of lower concentration of that substance, or down a concentration gradient. Click the picture to see what happens to the molecules over time.
Okay, so again,
You've probably experienced this in a room when someone arrives freshly doused in perfume or cologne. Those nearest the perfume smell it first. Then eventually the smell permeates the air in the entire room, reaching equilibrium.
okay, so the molecules are going to keep going until they can't go anymore. That's what we mean by equilibrium. Gas molecules don't like each other. So they will try to get as far away from each other as possible. So in the bottle, we call that an area of high concentration. There, all the molecules are closely packed together. As soon as you spray the little pump, you spread them out into the room, and they don't just stay right in front of you. They try to spread out as much as possible. So eventually the molecules will reach all corners of the room. And then what we'll talk about later too is the fact that they take up, I don't know, but when you all were in middle school, did you all went through looking at solid, liquid, and gas as a definition? And the definition of a gas was that it had no definite shape and no definite volume. And by that, they mean when it was in the bottle, it had the volume of the bottle. When you spray it out into the room, now it's taking up the whole room. So now it has the volume of the room. So the volume changes depending on what container it's in. Okay, so that's what gases do. Liquids, when by definition, have no definite shape because they take the shape of the container they're in, but they do have a definite volume. So if you have a cup of water and it's in a glass, then it takes the shape of the glass. If you take that cup of water and pour it in a bowl, you still have a cup of water. So it has a definite volume, but now it has the shape of the bowl. If you pour it on the floor, you still poured a cup of water on the floor, but now it's spread out over a wider area, so it has a bigger volume. So a liquid has a definite shape, no definite volume. Takes the shape of its container. Solids have a definite shape and a definite volume. So you need to remember, let's just review from way back when. So if I have a cube, a block cube, whatever size that is, that's its size. That's its shape. It's a cube. And it takes up a certain amount of space, and it's always going to occupy because those molecules aren't moving. So it has a definite shape, definite volume. So remember, solids, definite shape, definite volume. Liquids, definite volume, no definite shape. Gases, no definite volume, no definite shape. Okay? All right, so that's what she means by that. Those molecules are just spreading out all over the room.
Diffusion across a cell membrane. Water, carbon dioxide, and oxygen are some of the simple molecules that will cross the plasma membrane by diffusion when a concentration gradient exists. They would be able to move between the phospholipids from one side to the other, as shown in the picture. The majority of the molecules move from higher to lower concentration, although there will be some that move from low to high. The overall or net movement is thus from high to low concentration. Eventually, if no energy is put into the system, the molecules will reach a state of equilibrium where they will be distributed equally throughout the system. Molecular movement is still occurring even at equilibrium.
Okay, so equilibrium means again that there's an equal number. Like the first picture, it's kind of in 3 frames. The first part, all the molecules and those little blue dots are on the outside. That's our area of high concentration, and there's nothing on the lower box. And then in the middle, some of the molecules are passing through, and you can, if you look real close, I can't blow this up, but if you look real close, some of those blue dots are passing through the cell membrane, and now they're on the other side. And it will keep doing that until there's an equal number of blue dots or molecules on either side of the membrane. Okay, that's equilibrium. Then it'll stop moving. Okay? It won't keep going. It'll reach equilibrium, and it's happy. There's an equal concentration outside, equal concentration inside. And like I said, the cell has the ability to maintain that. It doesn't just allow things to flow in freely, or like we said earlier, it will pop, and it doesn't want to do that. So it knows how to regulate the contents. Okay. What else do I want to say about that? Okay, I'll come back.
Carrier proteins facilitate diffusion. Some large or charged molecules cannot cross the membrane without proteins that help or facilitate diffusion. Carrier proteins embedded in the membrane serve as pores or channels, letting specific molecules pass. This movement of molecules down a concentration gradient by use of a transmembrane protein is called facilitated diffusion. The protein often changes shape, similar to a revolving door or a movable bridge.
Okay, but this is still going to be passive transport. It's just that they get a little help. Okay, so again, you have those little green molecules outside, and they make them green because they are different from those blue ones that are able to flow through. These are too big to just flow through. So they find these channels within the membrane, and the membrane recognizes this is something, and it doesn't open the door for everybody. So like she said, it's like a revolving door. It knows, again, what it wants to come in and what it doesn't want to come in. So the things that they want to come in that are too large, they will open the door and let them in. And notice it opens and closes, so it kind of spits it in and then closes on the other end. And it does the same thing in reverse. It can send things out the same way.
Osmosis is the diffusion of water across a semi-permeable membrane. Since osmosis is a special type of diffusion, water would move from areas where there is more water, or high water potential, to where there is less water, low water potential. In this diagram, the solutions in the beaker are separated by a semi-permeable membrane, which is represented by the red line. The membrane only allows the pink water to pass through, and not the solute, which is represented by blue circles. Water potential is higher on the left-hand side of the beaker initially, compared to the right. The solute decreases water potential. Net water movement is from high water potential to low water potential until equilibrium is reached. The resulting volume in the beaker on the right may be different, but the overall percentage of water or water potential on both sides is the same.
Okay. I know that looks weird because it's a beaker, so that a beaker has definite boundaries to it. But if this was the cell, the red dot in the middle, the dotted line would represent the cell membrane. And what she's saying is the pink part is just water, but the little circles represent things like molecules or salt or something like that dissolved in the water. Okay, so notice there's only a few molecules on the left side in the first beaker, but a lot of pink. So that means there's a high concentration of water. And while it looks like it's an equal level of water on both sides of that line, there's a membrane dividing those. So there's a higher concentration of molecules on the right side than there is on the other side. So the water is going to want to go that way. It's going to want to go in the area where there's less water in between the spaces, so to speak. Okay, so it shows you, the arrow shows you in the next beaker where the water has gone through, and now there's a low amount of water. Now notice the number of molecules didn't pass through, just the water. So where we started with, let's say 7 little dots on the left side, we still have 7 little dots on the left side, but we have the water level has gone down. Now on the right side, the water level has gone up because it flowed from an area of high concentration to low concentration, and then it stopped. So while it looks low on this side, those little dots are taking up space. And that's the other thing you need to remember with matter. No two things occupy the same space at the same time. So the molecules in the water have to have their own space. Okay, so the water now has made those molecules spread out where they were all jammed up together over here. Now they're spread out because there's more water molecules in between those spaces. All right, but what she's saying is we still have the same amount of water. Okay, it just moved from one area of the membrane to the other. So this is a little different than what we were. So see, but the overall percentage of water potential is on the same on both sides. It's just spread out a little different.
Tonicity is the measure of how much water versus solute there is in a solution. If we can identify a solution as one of the following, we can compare it to another solution to predict the direction of osmosis. Hypotonic solutions are those with less solute. Hypertonic solutions are those in which more solute is present. Isotonic solutions have equal concentrations of substances. Their water potentials are equal, and water would move across the membrane in equal amounts.
Okay, you need to know those vocabulary words. All right. So hypotonic, again, you've got a lot of water on one side, but a little bit of water on the other side. Isotonic said that they're equal. Okay, so hypo, hyper in that first one. Isotonic, where even though the picture looks unbalanced, there's the water volume, the water concentration, sorry, is the same on both sides. All right, so what I need you all to do is to write down those definitions, because those are the definitions you need for that worksheet. And then we're going to compare these definitions to the pictures on your worksheet. I'm going to stop for a minute, let you write that down. Hopefully you have your Canvas page up, because I'm going to stop sharing for a few so I can do attendance, and then I'll share again. But you're writing down these 3 definitions, because those 3 definitions are what goes on that worksheet to go with those pictures. All right, I'll be right back.
Miss, I came a little late to class. What worksheet?
I think you already did, because I saw where you submitted it. But give me 1 second. It's cell transport. I'll show it in just a second. Give me one quick minute to do this. I'll be right back. But I think 2 people have submitted, and I think you were one of them. Okay, who are we missing? Isabella. All right, while I'm doing this, folks, remember we are testing next week. If you look at your homepage, you know what date. Actually, yours is Monday. A week from today, so this is the last new information that we're doing. Monday for 5th period is 9-week exam. So be preparing for that. I don't know what's happening with GoGuardian. It's not helping me right now. I should see everybody looking at transport. Okay. And I have to keep watching. People have been getting bounced out all day long. And then I have to keep an eye because then it come back in. Mhm. All right. And I need everybody to be on that worksheet. Not, and folks, that's the other thing. And if folks want extra time to turn in late work, it's hard to give you extra to not take off the late points off of it when I know you had enough time to do it in class if you were actually working on it. And then I also give extended because some of y'all have extended time, and I try to give that as well. So it's not due right away, but if you are doing the assignment when it's given, you have enough time to get this done. So everybody should be writing those vocabulary words down. I don't know what is going on here. Everything is spinning round and round. I think I have established the 3 people who are really not here. Tuesday, I have tutorial. If you still need help with something, 1:30 to 2, I will be on Zoom so that I can help you with that. All right. So I said, write that down. And somebody asked me, what worksheet? All right, we're going to come back to that because we're not quite finished with that. But in your module, and this one actually is in the module, you have something right after the cell transport lesson. You have, and I'm going to change the date on it because today's the date for that, cell transport review sheet. Okay, so this is where we are right now. We are talking about what happens to an isotonic solution, a hypotonic solution, and a hypertonic solution. So I'm going to, this is where we're trying to figure these words out right here. So this is the worksheet we're talking about. So I'm going to, oh, I'm not sharing. That would help if I was sharing, wouldn't it? I pulled up the worksheet and you're not looking at it. Give me 1 second to do that. Yeah, go to your Canvas module and download that worksheet that says cell transport. It's right underneath the Canvas lesson. And we're looking at hypertonic, isotonic. I asked you to write those 3 definitions down. All right, let's look at diffusion first.
ways diffusion happens across the cell membrane. Transport across the cell membrane, it can happen in two ways, passive or active transport. Passive transport means it doesn't need extra metabolic energy like ATP, while active transport, it needs ATP. Diffusion is a form of passive transport, and why it's passive is because the movement is along a concentration gradient. Across the cell membrane, diffusion can happen in two ways, simple and facilitated diffusion. In simple diffusion, the substance doesn't need help getting across the membrane, while in facilitated diffusion, it needs help, like from proteins. An example of this would be the carrier proteins. And we'll get to the different ways in a bit, but first let's see what diffusion is. To understand this, we take two solutions separated by a membrane. The solution has a solute and a solvent. So for example, in a solution of salt water, salt is the solute and water is the solvent. The concentration of the solute in the solvent is different in the two solutions. One is higher and one is lower. The difference between the two concentrations, that creates a concentration gradient. Now let's assume that the membrane is permeable to the solute, which means it's going to let the solute pass through. Molecules from both compartments have kinetic energy and keep moving around, bumping into each other and into the membrane. So the chances of them crossing the membrane will be higher when the concentration is higher. So the solute diffuses from higher to lower concentration until the concentrations of the two solutions are equal. This is equilibrium. So what drives them to move is the kinetic energy of the molecules themselves. No additional ATP was required. Since diffusion happens from higher to lower concentration, the movement is along or down the concentration gradient. Even at equilibrium, the molecules, they still keep moving around, but the concentrations of the two solutions, they stay equal, and there's no net diffusion that happens at equilibrium. Now the same thing happens across the cell membrane. Substances diffuse into and out of the cell depending upon the concentration gradient, from high to low. But there's a barrier in between the cell membrane, so for the substance to diffuse, they'll have to get through that membrane. The membrane is a lipid bilayer, so if it's something that's lipid soluble, like oxygen and carbon dioxide, it can diffuse across the membrane from high to low. So one of the factors that affects the rate of diffusion is lipid solubility. What else can affect it? The size of the concentration gradient, inside versus outside. If there's a bigger gradient, meaning there's a bigger difference between the two, the rate of diffusion will be higher. Smaller solutes again increase the rate of diffusion. But what if there's a thicker membrane? That means there is more distance to travel, which will slow down diffusion. Similar to that is surface area. Increasing the surface area would increase the rate of diffusion. So these are just some of the different factors that can affect the rate of diffusion in general. But what if the substance is water soluble and not lipid soluble? It means it can't get through that lipid bilayer, so it needs another path. And that's where proteins come in. So integral proteins, they can form channels. They can form pores, which are open at both ends for things like water. Now these are called aquaporins. These are water channels. They have a size limitation, so only water can get through. So for other water-soluble substances, integral proteins can form channels. Like for ions, like sodium, potassium, calcium, and chloride, they have ion channels. Again, they're selective, so they have a size restriction, but they also have a charge restriction. If the channel is lined with negative charge, it won't let a negative ion through it, even if it's small enough to fit. So they are size and charge selective, and they can also be gated. Very simply, that means they've got gates which could be open or closed. Open gates means ions can go through. Closed gates means they cannot, even if there's a gradient. So even if there's a concentration gradient or a difference on both sides of the membrane, if the ion channel is closed, the ions cannot pass through. But if the gates are open, they can move along the gradient from high to low. There are different types of gating, like voltage-gated channels, where the opening and closing of the channels would depend on a change in the membrane potential. This is like those voltage-gated sodium and potassium channels that we see working in the action potential. They could be ligand-gated, like with hormones or neurotransmitters, where after they bind, the channel opens and allows ions to pass. A classic example for this is the acetylcholine receptor on the motor end plate. When acetylcholine binds to its receptors, it opens the channel, allowing positive ions to move along their concentration gradient. Like sodium, it moves from high to low concentration. Channels could also be mechanically gated, like where pressure or stretch determine whether the gates open or not. So through open channels, when ions move, yes, they move along a gradient from high to low. They have a concentration gradient, so that's from higher to lower concentration. But since they are carrying charges, they can also have an electrical gradient. If one side of the membrane is positive and the other side is negative, a positive ion would move from more positivity to less positivity, and a negative ion would move from more negativity to lesser negativity. These electrochemical gradients are important when trying to understand so many things like the resting membrane potential, action potentials, and things like that. Now we saw how channel proteins work, but some substances need to be carried across the cell membrane, and they use proteins called carrier proteins. The carrier proteins, they transport substances from outside the cell to inside, or the other way around, depending on which way the concentration gradient is, but they still move from high to low concentration along the gradient, so it's not to be confused with active transport, where it goes from low to high. These carriers are used for substances like glucose, like the GLUT transporters that's facilitated diffusion. Amino acids also use carriers to move across the membrane. This kind of carrier-mediated transport, it can get saturated, which means after a while, as the concentration increases, all the binding sites, they fill up. So it can't transport anymore. The rate of transport has reached its maximum, and this is called the transport maximum. This kind of saturation wouldn't happen with simple diffusion because there's no carrier. And those are the different ways that diffusion can happen across the cell membrane. If this video helped you, give it a thumbs
All right. So she went through the different ways. So all of these are diffusion and it's passive low energy. She mentioned a lot of words, a lot of vocabulary. Permeable. Remember that permeability means it has the ability to pass through. She also used what was the other term she used? That I wanted to stop her while she was saying it. Oh, energy. The ATP molecule, you need to remember that the name of the ATP molecule of an energy molecule in a cell is ATP. It really is called adenosine triphosphate, but all you have to remember right now is ATP. All right, and I'm gonna get back to this in just a second. So hang on with that one. That really wasn't the one I wanted. But it was good. Okay, this is the one I want. All right, because you definitely need a visual for this. All right, but hopefully everybody's already written those vocabulary words down, so you'll be able to follow him as he goes through the difference between hypertonic, and isotonic.
Isotonic, hypertonic, and a hypotonic solution. Take a look at these red blood cells. and the effect of different solutions.
All right, I'm pausing this. All right, I want you to draw this picture, okay, on a separate sheet of paper somewhere, because you need a visual for this. And a lot of times on tests, these are the ones that they give you. So red blood cells have the ability to take in water and let water out. And so you want to have just a circle with some weird looking cells in the first one, and those are for hypertonic. They're going to explain in a minute. Hypotonic, they remember we said is equilibrium, so they look nice and round and pretty like what red blood cells are supposed to look like. On the third one, hypotonic, they have taken in so much water that some of them are starting to burst. All right, so the ones in the first one are shriveled up because they've lost water. The ones in the middle are just the right size. It's like Goldilocks and the Three Bears. And the last one is too much and they burst. So take a minute to draw those three pictures. You need to have that visual for you to go with those so that you can properly answer which ones, what is happening. Because you have to write something on the worksheet, in those columns on the worksheet, as to what is happening. So I have the worksheet handy too. Okay, I'm gonna stay here for about 2 minutes because it doesn't take long to draw these. And you don't have to draw as many cells as they have, just draw a few. So draw some wrinkled up in the first circle and label it hypertonic. Draw some nice round pretty ones in the middle, and that's isotonic. And then some that are big and fat and ready to burst for hypotonic. And then I'm going to take the caption off just for a minute so that you can draw the picture underneath. So you have the picture underneath where you have water and the water is leaving, so it's shrinking. In the middle, you have two arrows, one going in and one going out, and that's the equilibrium. If the same amount of water is going in as the amount that's coming out, so they're nice and round. On the third one, the arrows, both of them are going in and the circle is getting bigger, okay, because the cell is filling up with water. So draw it just like that. The first one, you want two arrows, same size, going in the same direction out, and label that water. Second one, you want two arrows going in opposite direction, label it water. And the third one, you want two arrows pointing into the cell. So write H2O inside the cell. So you got to have that word H2O in each picture. So again, on the first picture, all the water's coming out, no water in the cell. It's shrinking up. Second picture, there's some water inside, there's some water outside, so each arrow has the word H2O on it. Third picture, both arrows are pointing in and all the water is in, so the H2O is inside. All right, give you another minute and then I'm going to let them start talking again. And again, I hope you're drawing this because it helps. You're going to see pictures like this on the test. So please be drawing. Notes help you.
Let's figure out why sometimes a red blood cell stays the same, sometimes it shrinks, and other times it swells. To begin with, it'll be helpful to know the difference between a solvent and a solute. Let's look at coffee. The solvent is what the solute is dissolved into. The water is the solvent, and the cream, sugar, and coffee are the solutes.
Right. Again, those are vocabulary words that you need to be familiar with. Okay, the solvent is the things that stuff dissolves in. The solute are the things doing the dissolving.
Now, in our example, we're going to use salt water. In the example, the blue circles is the solvent, water, and the white circles are the solute, salt. An isotonic solution is equal. Iso meaning equal, and tonic meaning strength. So the solute and the solvent will travel in and out of the cell equally, and the cell will stay the same. It's equal. Now, a hypertonic solution is different. Hyper meaning above, and tonic meaning strength. And notice that there are more salt or solute than solvent outside the cell. As a result, you have a higher concentration of solvent inside the cell. So the solvent travels out of the cell, and the cell will shrink. The solvent always travels from high concentration to low. Now, hypotonic, hypo meaning below, tonic meaning strength, and notice there are very little solute outside the cell, and a higher concentration of solvent outside the cell. So the solvent flows into the cell, remember high to low, and the cell will expand. I hope that's been helpful in knowing the difference between isotonic, hypertonic, and hypotonic. Thanks for watching.
All right. So I'm going to make sure this will be in your playlist, so you can watch that again if you need to. But we are going to look at the worksheet now. All right. So now that you drew all those pretty pictures, you should be able to put a check mark on what is happening. So isotonic, we said that's equilibrium. Does it cause the cell to swell, or does it cause it to keep shape? I mean, does it lose its shape? Does it cause osmosis? That's the movement of the water. Or does it cause it to shrink? So we're going to have I'm going to tell you, it doesn't change shape, right? That's going to be the normal cell. So you should have a check mark next, excuse me, not two. So osmosis is the movement of water. So remember we had our arrows going back and forth. So you got two checks in this column. It doesn't change the shape, but it does allow the water to move back and forth. All right. Hypotonic, which one is that? Is that going to cause it to swell, or is it going to cause it to shrink? You tell me. Somebody type it in the chat or just call it up. Because you wrote these on your lovely pictures. Where are you going to put your check marks for this one? Water is going to move, so we're going to check osmosis. So osmosis actually is going to be checked on all of them. Yes, we're looking at the column, the second column. So the first column, you should have two checks. One next to doesn't change the shape, and then one check next to causes osmosis. Now I'm in the second column. If we're hypertonic, where are we putting the checks? And I just finished saying you're going to have a check all the way across for causes osmosis, because water is going to keep. All right, it's going to swell. So you're going to put the check mark on the top one. So, and on causes osmosis. That means with hyper, you're going to put a check mark for cell shrinks and causes osmosis. So we've just completed that first box for you. All right. During the video they talked about all of these vocabulary words. So you want to put A, B, C, or D on the line next to what each of those does. Then you want to match these A, B, according to its correct description. So you're going to need to go back and add additional information, because they're the same words. Add additional information, some of them are the same words, as to what they are going to do. So take a few minutes to do that. All right. This one is what they were just talking about. Glucose, remember that's our macromolecule, sugar molecule. So it's going to be bigger than our regular water molecules. And notice the arrows are telling you which way the movement of the molecules are going. So look at you're going to label this diagram of cells with the term, is the first picture diffusion? Is it active transport? Is it osmosis, or is it equilibrium? And look at what the molecules are and which way the arrows are going. So you're going to add, so looking at what the picture is showing you, you're going to add the word underneath it, and you can use the words more than once. You're going to add the word diffusion, active transport, or osmosis or equilibrium. Okay? And then you're going to look at this one, and this one we might do together. All right, here you got some pictures. Let me just give you a few minutes because it's almost time to go. So I'm going to give you a few minutes just to work on this top part, and then we'll look at the other part later. Okay? We're going to, but if you can get to these, because we need to talk, we haven't talked about what these those terms endocytosis and exocytosis are, and that's what this last question is about. So you see if you can get as far as question 3 on this section of osmosis practice, and then we'll talk about the other ones next class. So we haven't defined those 2 words yet. Oh, while it's in your definition, in your glossary, we haven't talked about it yet. So nobody should be turning the worksheet in yet, because we're going to try to go through all these. And this, folks, and the fact that we're doing this together is part of our review, because this will be on the next test, on the 9 weeks test. Okay? All right. So I'm going to stop sharing and let you work on that. And again, you're given time to do this in class. Be doing it. If you have any questions, please ask. Are you comfortable with it, or do I need to send it back to you? I know 2 of you did submit it already. So in our discussion, do you feel comfortable that you have the right answers? You have time to look at it and resubmit. Oh, I didn't want to do that.
Miss, can you see my camera?
Give me one sec. All right, I can now.
That's weird, because on my side, my camera is just completely black.
Oh, well, I see you. Yeah, I'm looking at the page. So right now, yeah, I see you. So you're on camera. I got a couple of people who are not, but I see you. And folks, remember, y'all are all supposed to be on camera. Some of y'all log in and then take a walk. Look at this class. And they got a couple of y'all. I'm in the process of sending out emails and making phone calls. A couple of y'all need to get it together. We don't want to fail the first 9 weeks. All right, so I've got a couple of you have turned the worksheet in, and that's like half of you. That's wonderful. However, still make sure that you understand the vocabulary. And again, we are preparing for a 9-week exam in 1 week from today. So use this time to review all of the other modules if you are comfortable with this one. And again, I'm going to consider this as reviewing this one. So when I go back and review the other modules, I'm not going to come back to this one. And who was it emailed me? Somebody emailed me. Did I look at your worksheets? Dallas. All right, so I will look at that right now. Yes. There's a blank next to your plant near pot. Okay. Let me get my page. All right, Jocelyn, I need, and with the Nearpods, I always have to go in and check them. And sometimes when I check, y'all aren't there. So I will go back and check on your Nearpod. Last time I checked, you only had the animal cell, but not the plant cell. That's why I didn't check either one. All right, and some of y'all are like that. Last time I checked the Nearpod, some of you had not done either plant nor animal. Now, if you did one of the, and I'm only putting the grade in once you complete both, so there's no 2 grades, but you have a plant cell and an animal cell. So if you only did one and you need to do the other before I put the grade in, you're getting 5 points for each one. So like I said, there's a good handful of you who didn't do that. Let me do a quick check on that Nearpod right now. And again, folks, I mean, when y'all email me and say, oh, you didn't put the grade in. Well, when I was looking for the grade, it wasn't there. And there's only so many times I'm going to go back and forth looking for the grades. Especially with things like Nearpod, where I have to check another source to get the grade. So like I said, some of y'all sitting there, oh, I finished, I did everything, but I still see a lot of zeros in my grade book. So anytime you finish one thing and you still got some zeros, you got some work to do. All right, checking the Nearpod. Which one were you missing? Plants. And that Nearpod could not have been any easier. You just had to take the time to do it. All right. Neve, you still have not done yours. From what all right, I got everybody else. That's if you signed in to do it. Oh, okay. I see you went in and did it on another day. Okay. Sorry, Neve. You got 2 logins. So you're good on that one. All right, it's Sakari. I don't have you logged in at all. Troy. Dallas, I don't have you logged in for that one at all either. Lucas, I don't have you logged in for the plant cell either. Ethan, I don't have you logged in for the plant cell either. Okay. And again, I can't grade what you don't do. Okay. Checking the animal cell now. Y'all have the codes for these. They're in the assignment folder. Okay. All right, Troy, you're good. Neve, you're good. Ziana, you're good. Josh, you're good. I think you were the one who emailed me, so you're good. So I will put the update the grade book for those. All right, Dallas, I still don't have one for that either. So that's 2. That's big 0. Troy, you're good. Caleb, good. Lucas, I don't have one for this one either, so not good. This is what I'm saying. Y'all are logged in, and I'm sitting there watching you, and that's okay. Like I said, it's not that you needed to send me a picture. It's just that I needed to go back in and check. But the last time I checked, it wasn't there. So it's there now. So I will put those in the grade book right now. All right. So Jocelyn, you're good. I will fix that immediately. Where is the grade book? All right. So again, I still have too many zeros for that. And okay. Dallas, I fixed your cell. Oh, wow. Now you don't need to send me pictures. I got it. I got it. I got it. All right, Ethan, I got your cell pictures, but I don't have any functions. Delete off of that. Okay. Give me 1 second. Nearby. Just 10. Whoops. Okay, folks, it is past time. So if you are good, you are welcome to go ahead and log out. I'm just fixing these Nearpod scores. And so if you give me about 5 minutes and you refresh, you should see an upgraded Nearpod score if you were missing one. And then those who really didn't do it, you're going to see a 0. Because right now it's blank. You can log out. It's time to go. So Brandon, have a good afternoon. Okay, that's been upgraded.